Hello everyone. Today I want to talk about Transformer. Not the movie Transformer, but the Transformer that changed the AI world. So I was under the impression this is very popular and everyone that works in uh, my team, which is in Google, should know about this. But last year when we had the summit and we were brainstorming about using transformer like architectures to improve our features, I realized that it's not the case. Like most of our team members actually are not familiar with this. So that's the point when I thought, okay, I should spend more time and share it with like everyone. It's possibly not as common as I thought. So I want to break it down into several key topics. And today is the first topic, attention mechanism. So I want to start with something seems unrelated. So how to smooth a noisy time series. So first graph, X, it's a noisy time series data. There's X0 to X55 numbers, and they form a vector X. Now we have a reweighing function, we call it W3 or X3. So it's a normal distribution-like function. What it does is it will filter data that's like far away of X3 and amplifies the data that's close. So if we multiply the filter reweighing function with the time series data X, like X0 multiply W03, X1 to W01, and we add all the values together, we're going to get a new value y3. So here is the mathematical formula. Y3 equals to W3 dot product X. Similarly, Y4 equals to W4 dot product X. So W3 is a vector, X is a vector, so Y3 is a number. Similarly, Y4 is a number. And then with all the Y0 to Y5, it forms a new vector Y. And this vector is supposed to be better than X. The advantage is vector Y now have like other points context compared with X. So it's less noisy. So you can say Y3 paid attention to other points. Similarly, from Y0 to Y5, they all paid attention to other points. I want to also say it's not necessarily like smoothing this function. It really depends on how you design the reweighing function, right? If your reweighing function is just flat, then your output y is going to be flat. If your reweighing function is just extremely pointy, say only W3 have value and all the others all 0, then it basically does nothing. Your y will just look identical with X. So it really depends on how you design your reweighing function. Okay, I guess the important thing is you understand with some reweighing function, now you have a new vector from X, and this new vector Y have the advantage of it has context. Okay, let's move to the next one. Before I talk more about transformer and natural language, I want to talk a little about word embedding. So word embedding is the representation of word, which is the smallest representation in the natural language programming NLP. So it's very important. It's a fundamental of how we develop in this field. So the definition is a word embedding is a representation of word. The embedding is used in text analysis. Typically, the representation is a real valued vector that encodes the meaning of the word. in such a way that the words that are closer in vector space are expected to be similar in meaning. That's a very long sentence, right? I want to show some example here. Let's simplify this word embedding. Let's say in the vector there's 5 values, and each of them is 0 or 1. In reality, it usually is a score, but let's say it's 0 and 1. So it's a vector, and first one is human, second is female, third one is male, and then it's bark or not, and then it's talk or not. Then for the word father, the representation, the word embedding is 1, 0, 1, 0, 1, right? It's human, it's not female, it's male, doesn't bark, talks. The representation of stud is 0, 0, 1, 1, 0. It's not human, not female, it's male. Barks, doesn't talk. So this is a pretty simple example of word embedding. So why is it useful? There are two big advantages, I would say. First one is the distance between vectors indicates the similarity between words. So you can actually take a look at these examples. Like from king to queen, the vector it's very similar to from man and woman, right? It captures real relationship in the real world, similarly to walking and walked, swimming to swam, and then like country capital relationship. The distance between the word embedding is a vector, and it indicates some kind of relationship. Next one is like words with similar meanings are represented by similar vectors. What it does, in the end, it aggregates like similar entities in very close clusters. Like if you, this is a 2D representation, but in reality it's very high dimensional. But it's just for you to see, like train, bus, car is clustered similarly. College, school, work, it's similar, it's one cluster, and on, in, with. So yeah, similar meaning words are represented by similar vectors. So now we know about word embeddings. So let's talk about the tension for like natural language. So here's a sentence. It's date is my favorite fruit. So date is a word that we use very commonly, right? And I would say 90% of the time it refers to the time instead of a like edible fruit. But like, how do we human knows date means fruit in this something to eat in this case? It's like human, we read the sentence and we see, okay, there's a fruit, and this fruit is referring to this date. So that's why date in this sentence is something to eat rather than the time. So similarly, when you try to tell the AI system like this has some other meaning, you can use attention like mechanism, right? So imagine like natural language needs the similar mechanism, like each word or token or data point needs context of others in the same sentence or paragraph. So for example, date in this sentence means an edible fruit instead of time, with the context provided by this fruit. However, this context is different from the previous context, right? The previous example, when we say context, it's basically similar, like proximity with our like filtering function. But we can't use proximity like we did before. We need a more sophisticated reweighing method, and it needs to have semantic meaning. So let's move on to the next one. So let's say here is a black box of reweigh and linear like reprocess. We first like partition date is my favorite fruit to like different word embeddings, so we can do like mathematical process to this natural language. So V1 is the word embedding of date, V2 is the word embedding of is, etc. So, and then we input this word embedding to this big box, supposed to be the attention mechanism. and then the output is going to be y1, y2, y3, y4, y5. And what we want is y1 is a better representation than v1 because it has more context of other words. So this y representation should have more context than v. So what we do is usually like this. So v1 is a vector. So dot product v1, it's a number. So it's a real value w11 with star. Similarly with all the w12, 13, 14, 15 star. And then we normalize it. So they add up to number 1. They add up to the value 1. And this is the weight that we need. And then we use this weight to reweigh v1. So w11 dot product, not dot product, this is a real value, this is a vector. So w11 multiply v1 and then same with v5. And we have a new vector. This is like a linear reweighed y1. So reweigh all vector towards v1, so it has a context of other words embedding. So we do similar like process for all the other vectors, y2, y3, y4, y5. And we have the new representation of date is my favorite fruit. And now the y vector have context. And this is the basic for attention mechanism in natural language. So I will continue with all other key concepts in the following series. Hopefully this is helpful. Thank you, everyone.